In this video, I'll be showing how to create a high voltage electron generator that fits neatly inside of a glasses case. This device pulls in electrons from the surroundings through one wire and feeds them out of another so that anything touching the second wire is electrified with a static charge. Using a simple harness to attach this device to my leg and to the bottom of my foot, it is able to pull electrons from the ground I'm standing on and use them to build a static charge in my own body. This means that at the flip of a switch, I gain the ability to shock any object I touch. Sand and other fine particles turn into a dust storm when brought in close proximity to the high voltage charge. A static discharge from this device creates a strong enough electric field that it can even disrupt electronics from a distance. Direct contact is powerful enough to potentially cause damage to circuitry or even corrupt data. I had to be very careful during this video not to touch my camera while I still carried a static charge. The electronics used in this project are really in a very simple configuration, all built around powering a negative ion generator. This is the component of our project that is capable of producing the high voltage electrical charge that we end up with. It does so by pushing electrons out through the wire that currently has the prongs attached. We need a way to make this run off of a 9-volt battery, but it is not as simple as just plugging it in. The ion generator is made to run off of alternating current, like what is found in the wall sockets of a house, but a battery only provides direct current, like what is found in a car. To allow the battery to provide this different form of electricity, we will be using an automotive power converter. The converter is first taken apart so that we can see the internal components. The circuit board should be easily removed simply by extracting one or two screws. The power inputs to this converter should be fairly obvious and take the form of a red and black wire attached to a spring. We will be installing our on-off switch in the middle of the red wire between the battery and the converter, but to do that we will first need to trim the spring off of the end of both wires. We will be needing to use a soldering iron shortly, so now would be a good time to get one warmed up. On one side of our on-off switch we will be attaching the red wire that leads into our power converter. On the other side we will be attaching the red wire that comes off of a 9-volt battery harness. The red wire coming off of both of these devices must have a portion stripped off of the end so that we have room to solder onto the switch. The type of switch we will be using for this project is an on-off sliding switch, but any type of on-off switch will work. Before going any further, we need to cut a short piece of heat shrink tubing and place it over the end of each red wire. The stripped portion of the wires can now be twisted around each terminal of the switch and soldered into place. Once the solder cools, the heat shrink tubing can be pushed up over the connections, and using a lighter we can shrink it down to insulate them permanently. Changing our focus now onto the black wires, we can simply connect the two in the middle with a splice. I, however, prefer to run the black wire directly into the power converter, and to do that we remove the old black wire that is coming off of the board. To do this, we press a soldering iron up against the connection point that the black wire is currently making to the board. The solder will quickly melt and the black wire will free itself. To connect our wire from the harness, we first will take a little extra solder and put it on the old connection point on the board. We then heat it to its melting point and press the new wire from the battery harness into place. The installation of the battery harness is now complete. With a battery snapped into the harness, we can confirm that the converter is working properly by flipping the switch and looking for a red indicator light. To avoid getting shocked during the rest of the assembly process, it's a good idea to once again remove the battery before continuing on. With the power supply complete, we can now finally move on to preparing the negative ion generator to plug into it. The end of the red wire is cut to remove the metal prongs, and the plastic sheath is slid off as well. The black and white wire are also trimmed down slightly, and the end of all three wires are stripped. The stripped sections of the white and black wire are each inserted into one of the output terminals on the power converter. A generous application of hot solder holds each wire in place. The electronics for this project are now nearly fully assembled, all except for installing a long ground wire to one of the converter's output terminals. It can be quickly soldered into place right on top of either the white or black wire. This ground wire should be long enough to reach from the middle of the user's leg all the way down to the bottom of the foot. This completes all the electronics for this project, so we can now make sure everything is working properly by reconnecting the battery, turning on the power, and making sure that a spark arcs between the ground wire and the red wire coming off of the ion generator. With the electronics fully functional, we can now move on to installing them into a protective glasses case. We will need to make several small modifications to the glasses case for it to accommodate our electronics. The first will be to drill a hole for the wire coming off of our ion generator to extend through. We can find where the hole should be drilled by placing the ion generator into the glasses case and sliding it all the way to one side. A mark is then made in the case just slightly in front of where the red wire comes out of the generator. The hole drilled should be just barely large enough that the red wire can slide through without getting pinched. The next step will be to position where the on-off switch will be placed, and to do that we will need to insert all the electronics into the glasses case approximately where they're going to fit best in the end. The switch should then be positioned somewhere along the wall of the case where there's going to be the most room on the inside. We once again mark the position, then remove all of the electronics and cut that section out of the wall with a hacksaw blade. We can now start fitting the electronics into their permanent positions, starting with the electron generator by pushing its wire through the hole we previously drilled. Right in front of that, we insert the power converter, which is hot glued into place. The switch is then inserted into the section we prepared for it in the side. It can be hot glued into place, but you must be very careful not to get any glue into the internal components or it may not function properly. Our final step is to either drill a hole or use a file to cut a groove into the bottom of our case for our black ground wire to extend out of. Finally, the battery is inserted and this device is good to go. With the flick of a switch, electrons start flowing from the red wire. A healthy arc should now be created between it and the ground wire when brought in close proximity. We can now begin work on the leg harness for this device. On closer inspection, we can see that the harness's primary purpose is to bring the red wire coming off of our device into good electrical contact with the side of the user's leg. The case full of our electronics is simply velcroed to the outside of the sleeve for easy removal and adjustment. The plastic sheath for this harness can be cut out of the side of a 1-gallon bottle, such as this gallon of windshield washer fluid. With the bottle emptied and rinsed, we can move on to cutting a sheet of plastic out of its side. The plastic sheet is now fitted around the wearer's leg, and the corners that overhang are marked to be cut off. Once the sheet has been cut along the lines, all the remaining corners are rounded off so there are no more sharp points to jab into the wearer's leg. The glasses case is then lined up on the back side of the sleeve and a mark is placed about a ½ inch in front of the red wire. A hole is drilled through this mark and the wire extends through it. With the case lined up how we want it, we can now attach it to the sheet with 2 strips of sticky side Velcro. For a good electrical connection on the inside of the harness, we will be using a piece of an aluminum can to make a better connection between the wire and the user's leg. The strip of aluminum cut from a soda can must be sanded on both sides to remove both paint and other buildup that might prevent a good electrical contact. The aluminum is then taped to the inside of the harness with the end of the wire securely underneath. The large contact area will help the passage of electrons go unnoticed by the wearer. With only a small contact, the wearer would be feeling an uncomfortable shock the entire time the device is turned on. We can now proceed to attach more sticky side Velcro to the leg harness, positioned in such a way that it will be able to open and close. We can now move on to creating the foot harness for this device, which is attached to the end of our black ground wire and is composed of a piece of dual-sided Velcro and another piece of an aluminum can. To start, we take a large strip of dual-sided Velcro, which is usually found in the form of cable ties, and cut both oddly shaped ends off. Another sanded aluminum strip that was cut from the side of a soda can is taken and wrapped entirely around the center of the Velcro strap. A pair of scissors is used to cut a hole in the strap off to one side of the aluminum strip. This is what the ground wire will extend through. The end of the ground wire is pulled over the top of the aluminum strap and pushed down underneath it. A piece of tape holds both the wire and the aluminum in place. This project is now complete. By attaching the harness to both the leg and the foot, the user is able to shock anything within reach.